here, topic and widget, and there is a one-to-many relationship between these two, right? Topics contain many widgets. So to model that in Java, it would be just enough to just do the following, right? We would have a field called topics, right, that contains a collection of the children, right? Usually that's the way you model one-to-many relationships in Java. You have the parent having some collection, either an array or set or a map or list of the children. And if this were just a Java project, would be done. There's nothing else that we need to do, well, other than putting the setters and getters and whatnot. But because this is not just a Java class, this is meant to be mapped to a table, right, for storage, we need to go a little further. We need to tell the JPA library how is it that we want to map this to a relational database, right? There's no one unique way of doing it. We could map it using a mapping table, saying that these widgets belong to that topic. That'd be perfectly fine, right? We can implement not only one-to-many, we could implement a many-to-many, which might not make sense, that a topic can have many widgets, but a widget can belong to many topics. Maybe that makes no sense, right? So we would like to maybe go strictly not using a mapping table, but instead using a foreign key, primary key implementation. So to do that, we need to tell the JPA how is it explicitly that we want to implement that one-to-many relationship. All right, so let's do that. The way that we're going to specify this is that we're going to use another annotation. I'm going to say that the topic is participating in a one-to-many relationship, and we are on the one side of that one-to-many relationship. Okay, so the topic is on the one side, meaning one topic contains many widgets. Okay, and on the other side, right on the topic, widgets I meant, right? Sorry. A topic has many widgets. There we go. And so on the widget side, right, we want to do the inverse relationship, right? In Java, typically, it's enough to say that the relationship goes one way. It is from the parent to the children. Usually, the children don't know anything about the parent, right? Usually, we don't do a doubly linked pointers going backwards and forwards, right? Typically, we can navigate from the parent and iterate over the children. It's unusual that you would also want to go from the child back to the parent. But because we are mapping this to a relational database, in a relational database, it is very common that the relationships are bidirectional, right? That you can, just doing the primary key and foreign key, making them equal, you can navigate, get fields from both of the tables, right? From one table and the other table, just by making the foreign key and primary key equal in your where clause, right? So we need to capture that idea here. So to capture that idea, we are going to capture the two-way relationship by creating here a reference back to my parent. So this is my parent, right? So I can navigate from the topic down to the widget, and then back from the widget back to my topic, right? So having done this, we can tell JPA that this is what I'm going to use to implement the inverse relationship, right? Which in a MySQL database, a relational database, is just a foreign key. Right? So I'm going to use this as my foreign key. So we are on the many side of the one-to-many relationship, right? The topic is on the one side, and the widget is on the many side, right? So this is the many-to-one. So we are on the many side of the one-to-many relationship. And finally, on the topic, we need to specify that, hey, there is this other, the widgets are referring back to me, right? The way that the widgets are referring back to me is through a map I'm being mapped by the widget that's referring back to me with a field called topic, right? So this topic, right, is the name of the field that is being used to refer back to me, right? And this is what JPA is going to use to create the foreign key primary key relationship. Okay? All right, excellent. So I think the only thing left to do is to create the setters and getters. So we'll generate the setters and getters for the set and get topic, and back in the topic we'll need to create the setters and getters for everything. So we'll do core generate the setters and getters for all these, generate that. Excellent. Once we've done that, let's take a look at the tables before we take a look at this. So in topic, notice that we only have the columns for the IDs and the titles, right? Just the fields that belong to it. And then on the widgets, we only have the columns that we had created earlier, right? Oh, we do have a topic ID. Why do we have a topic ID? Oh, did we create in the widget? Oh, the widget, we had a topic ID, didn't we? Yes. We're not going to need this anymore, right? This was our attempt at capturing this relationship without foreign key, primary key. So let's remove that. We're not going to need that anymore. Where is it? There we go, topic ID. Right, that's going to be handled now by this object, right, which is going to create these fields. So let's, do we have any widgets here? We have some widgets. Let's, but if we look at the widgets, the way they were created, notice that the topic ID that we had created, the topic ID, see that? It's a varchar, but this actually should be an integer, right? Because the topic primary key now is an integer. Also notice that it's not declaring this as a foreign key. See that? So it's not really establishing any relationship because the topic table wasn't even existing, right? The topic table didn't even exist. But now we are going to have it. Let's blow away these two topics, these two tables, so they're going to generate it from the from scratch. So let's drop those two. All right. So let's rerun this. Oops. Okay. Yeah, we have this topic ID. So let's remove that. We don't need that. All right, so it created quite a few tables, and notice that this time around it did create the foreign key, primary key constraints. Right, so if we refresh our schema, we can go back and take a look at the new topics and the new widgets. In particular, let's take a look at the widget, how the implementation is right now. All right, we can look at the new and improved widgets table. You'll notice that now the widgets table, it still has a topic ID, but now it's an integer, and we have added the constraint that this topic ID is a foreign key, right? Referring to the topics table that now exists. You see that? Right? We want to enforce the fact that there's a one-to-many relationship. And in SQL, the way you implement that is by having the children have a reference back to the parent. The parent has no idea that it is participating in a one-to-many, right? It just has a primary key and doesn't know that some folks are referring to it, okay? Unlike Java. In Java, it is the parents who have references to the children. That's how you implement one-to-many. Anyway, so we have that. Now let's see if we can take advantage of this, okay? So let's do that. Let's start maybe creating a couple of topics, a couple of widgets. Let's add some widgets to the topics and whatnot. Let's do that.